Okay, last video for the day, at least for me. I don't know what kind of work you guys are accomplishing, but make sure you guys are staying on top of your studies here, guys. All right, it's important to stay in some sort of routine. All right, it'll keep you from going miserable, and it's always good to feel like you're accomplishing something. You know what I mean? Don't be sitting around playing video games all day. All right, not a real sense of accomplishment in that. Right? Not saying I discourage video game playing. I enjoy playing video games myself, but stocking up on, I don't know, things in whatever video game you're playing, there's no value in that. Right? Well, I digress. There's value in it, but it's not as valuable as your education. Trust me. Okay? Your points in Fortnite or Call of Duty, right, mean nothing in the real world. Okay? Knowledge means something in the real world. So, that being said, make sure you guys are staying on top of your work. Okay? Don't digress. Don't treat this as a break. And make sure you guys are reaching out if you have any questions. Okay? That's what we're here for. All right? And it's important you guys are staying on top of your studies, but also feel free if you need to email and bring up anything that's going on. Maybe you got some sort of, something going on. All right? That's what we're here for. As educators, as, mentors, okay? Please utilize us in any sort of needs that you guys have or concerns, and we'll try to address them the best we can. That being said, if you guys don't reach out, then we don't know. Okay? So it's important you guys tell us these things. Now, let's finish this up, and this will be the end of day 2. Okay? So in the diagram below, AB is parallel to DEF. Okay? Which means DEF is it's collinear. All right? It's a straight angle, if you will. All right, so A and E and B and D intersect at C. It doesn't say anything about bisecting. It just says they intersect. Okay, so nothing. It's not splitting anything up. The measure of B is 43 degrees, and the measure of CEF is 152 degrees. All right. It says which statement is true. Okay, so before I even start looking at what some of these statements say down here, okay, I'm just going to take into account what it is we have here. So we got these two lines that are parallel. All right, so let me just draw these in here. They're not going to look parallel, okay, but just pretend. So here's our two parallel lines. Okay, and now if you take a look, we got a parallel line cut by this transversal. Okay, so let me draw this in here. Let's see if I can see if this helps out at all. Maybe, maybe not. Okay, so two parallel lines cut by a transversal, which means, right, if that is 43 degrees, then this measure right here has to be 43 degrees as well. Okay, we call these alternate interior angles. Okay, that's what we have here. They're alternate interior angles. Let me erase that piece right there. Okay, now we can find out what this measure is, right? That's just 180 minus 152. It's 28 degrees, which means to find this measure right here, we would have to go, again, 180 minus whatever 43 and 28 equal, okay? Because don't forget, the area of a triangle is, or the area of all the triangles, let me restate that. The sum of the measure of all the angles inside of a triangle is 180 degrees. So in order to find this bad boy right here, okay, we're going to have to go 43 plus 28, and 180 minus 71 is equal to 109, which means if that one's 109, then that one is 109, because those are vertical angles. Okay? So our last piece, in order to find out what this last angle measure is, you're going to go 43 plus 109 equals 152. So 180 minus 152 is 28, which we already saw down there anyway. Okay, which makes sense because if you look at this line, whoops, again, we have the degree measure 28. Those are, again, alternate interior angles. Okay? So, anyway, we just found all the degree measures of those angles here. Okay? And we did that because I'm just assuming that that's probably what they're going to ask here. All right? So, which statement is always true? So, the measure of D is 28 degrees. Oh, that's wrong. The measure of ACD is 71. Okay, we want to assume something that's always true. So BCE, okay, that's not 109, so we can cross that one off. And the measure of A is equal to 43 degrees. Okay, so it has to be number 3, which makes sense because that's 109, and those 2 degree measures are 71. So that's your answer to number 6. Now if you look off to the right, we got 12% here. All right, so we're cutting it close here, ladies and gentlemen. So hopefully I can get this bad boy recorded before we run out of time. All right, so that being said, here's number 7. So what is an equation of the line that passes through the point 6, 8 and is perpendicular to the line with equation y equals 3 over 2x plus 5. All right, so I gave myself plenty of space over here, okay? So what is the equation of the line that passes through this point right here and is perpendicular? So which means we're going to take a look at this equation and we're going to take a look at its slope. So its slope here is 3 over 2. So what we need, okay, is a slope whose measure is the negative reciprocal, which is negative 2 over 3. Okay, so if you take a look at these equations down here, now again, these equations are all written in point slope form. Okay, all right, so we don't have to worry about putting it in slope intercept form or anything. Okay, they're all in point slope form. So let's just take a look at the ones that are wrong. Okay, this one is wrong and this one is wrong. Okay, because of these two measures right here. All right, those two lines would be parallel to that line there because the slope is 3 over 2. We're looking for a slope that is negative 2 over 3. So then we have to take a look at these points here, and then we also have to remember what the point slope formula looks like. So our point slope formula is written y minus y1 is equal to m minus, or m, and then parentheses x minus x1, okay, where x1 and y1 are just some point. All right, so it's just some point on the graph that we want it to go through. In this case, it's 6, 8. So if you look, 6 and 8 are both positive, which means when they get plugged into the equation, right, the signs in front of them still should stay negative, which means this one is out. So 2 is the correct choice. Okay. Let's take a look at number 8. So what is the equation of a line that is perpendicular to the line whose equation is 2y plus 3x is equal to 1? All right, so again, we're looking for an equation of a line that's perpendicular, okay? Which means, all right, well, first off, we need to find the slope of this equation right here. All right, in order to do that, this is in standard form. And standard form is ax plus by is equal to c. Okay, we want to put it in slope-intercept form. okay, which is exactly what we have over here. These are all slope-intercept form, okay, which is y equals mx plus b, which means we need to get y by itself. So we're going to go 2y plus 3x is equal to 1. So we subtract 3x, and we get 2y is equal to negative 3x plus 1. Divide by 2 on both sides, you get y is equal to negative 3 halves x plus 1 half, okay? So before we do anything, this is our equation right here. All right, so this is what we want, whatever equation we come up with, all right, we want it to be perpendicular to this line right here. So our slope in this particular problem is negative 3 over 2. So what we need is a slope of a positive 2/3. All right, so in order to come up with an equation that's perpendicular to this equation down here below, okay, what we need is we need a slope of a positive 2/3. And if you look over to your left, okay, we can start crossing off some of those answers, right? So this one's wrong, right? Negative 3 over 2, right? Negative 2/3, okay, that one's wrong, okay? Positive 3 over 2, okay, that one's wrong, right? Here's our answer right here. It would have to be that equation because we need a slope of a positive 2/3. That is number 8. 2 more, guys. 2 more. Number 9. Ooh, we're going to make it. We got 10% left. Good. Good. So, oh, there it is. It's giving us the warning, guys. Let the countdown begin. So what is an equation of a line that is perpendicular to the line whose equation is 2y is equal to 3x minus 10 and passes through this point? Okay, so we are going to have to use the point slope formula, which is y minus y1 is equal to m x minus x1. And then we're going to have to convert it into slope-intercept form, which is y equals mx plus b. Okay, so that is our process. So our first thing we need to do, right, is we need to figure out what our slope needs to be, right? In order to come up with an equation that's going to be perpendicular to this particular line here, we need to know what the slope of that line is. So in order to do that, okay, we just need to solve for y. So if you divide both sides by 2, make sure you divide everything on the right by 2. You're going to get y is equal to 3 halves x minus 5. All right? So that is what this equation is in slope-intercept form. And so now, let me make my pen smaller here. So now, whoops, 3x minus 5. All right, so our slope here is 3, 2. So what we need, all right, is the slope of this new line to be a negative 2/3. Okay, it needs to be a negative reciprocal of itself. So switching to blue. All right, and so now we're going to take this equation here. We have the slope we need, and we have our point. So I'm going to plug it into this point slope formula. So it's going to be y minus 1 is equal to negative 2/3 x plus 6. Okay, because we got that negative 6 in there as our point, so it turns to positive. Distribute. You get y minus 1 is equal to negative 2/3 x minus, so this is going to be negative 12 over 3, which is negative 4. Add 1 both sides, and you get y is equal to negative 2/3 x minus 3. Whoo, mama. And do we see that over there? Oh, we sure do. Sweet. Doesn't that make you feel so good when you get to the end and you see the answer over there? Nothing's more frustrating than when you get to the end and it's not over there. So I'm familiar with both scenarios, okay? One is better than the other. I would say finding the answer is 100% the better one. Okay. But that being said, sometimes you need a couple wrong answers in there in order to learn from your mistakes. So don't forget, mathematics is all about learning from prior problems, okay? Learning from your mistakes. Okay, so there's the answer to that one. All right. Now, finally, the last one. Okay, which equation represents a line that is perpendicular to the line represented by this guy right here? Okay. So in order to find a line that's perpendicular to this one, we first need to look at the slope. So our slope here is 2/3. So what we need is a slope of a negative 3/2. Okay, so I can already cross off a couple of those, right? So it has to be one of these, which is unfortunate because it means we're going to have to solve for y. So we're going to solve for this one first. All right, so we got 3x plus 2y is equal to 12. So you subtract 3x, you get 2y. Oops, doesn't look like a y there. 2y is equal to negative 3x plus 12. Divide by 2. You get y is equal to negative 3x over 2 plus 6. Which, do we see a slope of negative 3/2? We sure do. So it has to be number 1. Okay? And if you notice, we got that negative sign in the following one. So what would happen is you would subtract 3x to both sides, but then you would divide by negative 2. And so that negative 3x would become a positive 3x over 2. Okay? So anyway, so that one's out. So, down to 8%. All right. So, I'm going to email this to everybody. Okay, this is day 2. Parallel lines and perpendicular lines. Okay.